nonprofit that advises governments worldwide on how to better control emissions from all of the major modes of transportation. So today I'll be talking to you about recent trends in black carbon emissions from the shipping sector, why these are an important both health pollutant and climate pollutant, and then walk you through 3 recommendations for policymakers on how to mitigate their impact. Next slide, please. Could we load the presentation from Rutherford, please? Next slide, please. So, since we might be time constrained, I thought I'd actually start with the key messages here. What you should come away with today is knowing that black carbon is an important climate pollutant and also a health impact for the Arctic and communities located near the Arctic. You'll learn a little bit more about the magnitude of black carbon emissions from shipping and how they've increased over the past 6 years. I'll walk you through the benefits of switching towards distillate fuels in shipping, away from the current prevalent use of residual fuels like heavy fuel oil. And then I'll talk you through 3 concrete proposals to governments for how to mitigate the impact of these emissions. So let's talk about the magnitude of the emissions first. Black carbon is an important climate pollutant. It's emitted due to the incomplete combustion of residual fuels in marine engines. Depending upon the time scales of the metrics, black carbon is responsible for between 7 and 20% of the total climate impact of shipping emissions. 7% using a 100-year global warming potential, 20% using a 20-year global warming potential. According to IMO's 4th greenhouse gas study, black carbon emissions from ships increased by about 12% from 2012 to 2018. Now, black carbon is not only a climate pollutant, but it's also a health hazard. The solid particulate matter that ships emit, which includes black carbon, were estimated to have caused more than 6,000 premature deaths in 2012 above 40-degree north latitude. Now, ICCT in its own inventory estimated that ships emitted about 1,500 tons of black carbon above 60 degrees north in 2015. About 200 tons of that fell within the IMO's limited definition of the Arctic, which is shown in the blue outline on this map. Unfortunately, the black carbon emissions from ships have been increasing even more rapidly in the Arctic than the global average. The left panel on this chart shows how much black carbon was emitted from ships within IMO's Arctic, specifically from heavy fuel oil. That shows a 72% increase from 2015 to 2019. The middle panel is showing the same figure, but from all fuel use from ships in the Arctic. So that's heavy fuel oil, distillate fuel, and also liquefied natural gas. That increased even faster, 85% between 2015 and 2019. And this compares to a global increase of only 8% over that 4-year period. So the big takeaway is that black carbon emissions from ships are increasing 10 times faster within the Arctic than the global average. So what's the quickest and easiest way to control these emissions? Quite simply, it's to shift from the use of residual fuels to distillate fuels. Essentially the diesel fuel similar to what is used for on-road vehicles today. And doing so would have a number of benefits. It would reduce black carbon emissions by 50 to 80% relative to heavy fuel oil. It would also enable, it would reduce air pollution, that would be sulfur oxides, particulate matter, etc., without using exhaust gas scrubbers, which increase water pollution as a byproduct of their operation. Distillate would also enable the use of diesel after-treatment technologies, including diesel particulate filters and electrostatic precipitators, which can cut particulate emissions by more than 90%. And lastly, using distillate would reduce both the risk and the expected cost of fuel spills in the marine sector. According to our estimate, cleaning up a distillate spill costs about 30% less than cleaning up an equivalent spill using low sulfur fuel oil, and 7% less costly than cleaning up an HFO spill. So let's talk a little bit about ways that we can mitigate these emissions from the shipping sector. You may have heard that the International Maritime Organization is moving to ban the use of heavy fuel oil in the Arctic. That would have the impact of reducing black carbon emissions from the combustion and also mitigating some of the spill risk that I just mentioned. The challenge is that there are a number of large loopholes to IMO's approach. So the full ban will take effect in 2 years' time, but it has waivers and exemptions that are built into it. So, for example, ships that were purchased after 2010 will have a 5-year exemption from the requirements, and then near Arctic states, including Russia, the U.S., Canada, Norway, and Denmark, have the right to grant 5-year waivers for their ships operating in their waters. And so as a result, the HFO ban will not take full effect in reality until July 2029. Now, if governments move to not grant waivers to their ships, it would have a significant impact in cutting black carbon emissions. And this chart just shows if countries do not exempt their ships, it would lead to about a 70% reduction in the use of HFO within the IMO Arctic. The large majority of that would come from Russian-flagged ships operating in Russian waters. So that highlights the importance of that country in efforts to control these emissions. Overall, if the full exemptions and waivers are granted, we estimate that the HFO ban would still allow about 3/4 of the HFO fleet to operate in the Arctic through 2029. And the policy would only reduce HFO carriage by 30%, HFO use by 16%, and black carbon emissions by 5%. So you can see that there's a lot of room for improvement if IMO does go and eliminate these loopholes. The second policy that could be refined to control these emissions is in Europe. Under the Fuel EU Maritime proposal, Europe is proposing a goal-based approach to reduce the carbon intensity of marine fuels for ships that are operating to and from its ports. Currently, Fuel EU Maritime does not include black carbon emissions, and a simple step that Europe could take to reduce the impact on the Arctic is to, in essence, require the use of distillate fuels for voyages that are leaving its ports and operating within the Arctic region. And that could reduce black carbon emissions from those voyages by between 50 and 80%. The final policy recommendation is pretty simple. The International Maritime Organization has a series of climate standards for ships. that are currently all based on either a fuel consumption or a carbon dioxide basis only. They do not include other short-lived climate pollutants, including black carbon, methane, and nitrous oxide. So this approach has the potential to promote fuels that emit less carbon when burned, but emit larger amounts of these co-pollutants. And as a result, the net climate impact can actually increase from their use. So there is a paper into the next MEPC meeting from the Solomon Islands Pacific Environment and the Inuit Circumpolar Council to reform IMO's approach and do a full life cycle assessment of all relevant pollutants. This would help avoid some of the unintended consequences I just mentioned. So that's all from me, just those 3 policy recommendations for people to think about as we start to address these important impacts from the shipping sector. Back to you, Rosa.
Any quick question for Dan before we move to the next speaker? Okay. Thanks very much, Dan. We'll get back to you. Our next speaker is going to be Lisa Kupakala, and she's the president of the Inuit Circumpolar Council in Canada, and she's going to give us a presentation on building alliances at the International Maritime Organization, IMO, with a focus on black carbon and methane emissions. Over to you, Lisa.
Thank you for this introduction. And Andrew, thank you for the presentation up on the screen. So yes, I'm pleased to be speaking to you today about building alliances at the International Maritime Organization with a focus on black carbon and methane. We are all north and south dependent on a clean, safe, zero emissions global shipping fleet, and this is even more true for us Inuit in the Arctic. 3 things I'm hoping for you to take away from this presentation is Inuit depend on clean, responsible shipping to safeguard marine resources, and our relationship with the marine ecosystem is critical to our well-being and our way of life. Secondly, shipping black carbon emissions can be reduced by switching to available, cleaner fuels now. Black carbon can be reduced immediately. We just need to act. And thirdly, Inuit are the first indigenous people to be granted provisional consultative status at the IMO, which will give us a seat at the table to call for shipping rules that reduce climate impacts. Next slide. Allow me to tell you a bit first about who we are as Inuit. We are a marine people who live in the Circumpolar region, and our homelands transcend national borders, which makes us truly an international people. Inuit have rights to a vast coastline and marine region. We are over 180,000 people, one people, one nation. We live in 4 different countries. In Chukotka, which is part of Russia, in the Far East, in Alaska, part of the United States, in Canada, and in Greenland, which is related to Denmark. Slide 3. We're part of the Arctic ecosystem. As I often say when I speak to our culture and biodiversity in the Arctic are intricately tied. Importantly, we depend upon the Arctic sea ice, flow edge, and polynyas for our food security. Our knowledge of the Arctic includes the ocean and coastal seas, migration patterns of marine animals, current and wind observations, knowledge of ice and of the ice movements. All this knowledge, when co-developed with science, builds a greater understanding of the changes the Arctic is experiencing that directly impacts shipping. As well, we are bound to the marine environment and to the shipping industry. It's an essential service. Next slide. We know that Arctic shipping level traffic are increasing, and we see it, and the traffic will continue to increase significantly as the ice melts. The statistics you see on this slide are from a recent Arctic Council report looking at ship traffic over a 6-year period, showing a 75% increase in distance sailed and 25% increase in unique ships. NASA figures show ice melting 13% per decade. It's enormous, and we know that this will cause more ships to arrive, to pass through the Arctic. Next slide. Inuit. We are on the front line of the climate crisis. Inuit Nunat, our homeland, is warming 3 to 4 times faster than the rest of the planet. As the recent IPCC report has outlined, loss of ecosystems and their services has cascading and long-term impacts on people globally, especially for indigenous peoples and local communities who are directly dependent on ecosystems to meet basic needs. Given dire predictions and already observed impacts, action to reduce climate emissions from shipping is urgently needed, particularly black carbon, a short-lived climate force which is 20% of shipping's carbon dioxide equivalent emissions, has a disproportionately high impact in the Arctic. Black carbon can be reduced overnight, in some cases by 80%, by switching to clean fuels like distillate. Next slide. We're also concerned about the shipping industry's increased methane emissions. Methane is a potent greenhouse gas, so reducing global sources will benefit the Arctic. Methane is the second largest contributor to climate change and more potent than CO2 at warming the atmosphere. A major source of methane in the shipping industry is from the use and potential use of LNG as a marine fuel. We need to support alternative marine fuel solutions other than LNG over the next years to reduce methane emissions from the shipping sector. Next slide. Working towards efficient, clean, zero-emission and safe Arctic shipping is in all of our best interest and will require a collaborative effort. It's because shipping is so important to us that we began an engagement with IMO. IMO consultative status for ICC will ensure that our unique and independent voice, our Inuit knowledge, perspectives and issues are heard within this important decision-making forum. Next slide. To sum up, Inuit, we depend on clean, responsible shipping to safeguard marine resources. Our relationship with the marine ecosystem is critical to our well-being and way of life. Shipping black carbon emissions can be reduced by switching to available cleaner fuels now. Black carbon can be reduced immediately. We just need to act. Lastly, Inuit are the first indigenous people to be granted provisional status at the IMO, which will give us a seat at the table to call for shipping rules that can reduce climate impacts. And we wish to do this in partnership, in alliance with small island developing states and other allies within the IMO and around the world. Thank you so much.
Thanks very much, Lisa. Any quick question for Lisa or the next presentation? No? Okay. Thanks very much. That was very good, and hopefully you're staying around for the panel. Our next speaker will be Lena Hogan Isaacson, and she's with the IASA, the International Institute for Applied Systems Analysis. And her presentation will be on reducing methane emissions from human activities globally and in the Arctic Council member and observer countries. Lena.
I'm a senior research scholar at the International Institute for Applied Systems Analysis in Austria, where I have been for almost 20 years working on methane emissions, so global inventories for methane emissions as well as policy scenarios, so building scenarios into the future. So maybe you can take the next slide, please. So let me first just remind everyone why it's important that we reduce methane emissions. As you know, you might know, we are heading for a temperature increase of 1.5 degrees, probably in the next few years. And if we continue with business as usual, we will pass 1.5 degrees probably around probably before 2050 with only CO2 emissions. So it's really important that we reduce the CO2 emissions. But in the short term, you can see here the lower red line, that's the warming from methane emissions, which is around half a degree only from methane emissions. And so in the short term, one of the few options that we still have to stay below 1.5 degrees is to significantly reduce methane emissions, in particular to keep below 1.5 degrees in the next 2 decades. So let me start with a few key messages from this presentation. You might know about the Global Methane Pledge, which was negotiated the last COP in Glasgow. The signatories of the Global Methane Pledge is around 130. It was 125 when I did this slide. And they emit about 54% of the global anthropogenic methane emissions. But the Global Methane Pledge signatories, together with the Arctic Council member and observer countries, emit as much as 87% of global anthropogenic methane emissions. For the Arctic member countries, it's the oil and gas activities that dominate methane emissions, and this is also the sector where there is the largest potential to reduce emissions significantly at a very low cost in the next few years. For the observer countries, coal mining is the most important factor for reducing emissions very fast, and they account for a quarter of the emissions in the observer countries. And finally, emissions from the waste and agricultural sectors, these are the most difficult to reduce in the short term. So this picture shows now the total anthropogenic methane emissions. And the green one is the emissions that are from the signatory countries of the Global Methane Pledge. And as you can see, I don't know if it's possible now. If you can see in the right graph, these countries, if they follow through on the pledge, which means reducing, collectively reducing methane emissions by 30% between 2020 and 2030. And if they follow through on that, then they will be able to reduce the slope of the green to the right. And it will mean then that we come to an emission level that is comparable to the level where the world was in 2010. So we will need more significant reductions in methane emissions. And here I have split the global methane emissions into 3 different country groups. The first one is for the Arctic member countries, and the one in the middle is the observer countries. And to the right you have the rest of the world. And as you can see, for the rest of the world, most of the emissions are covered currently under the Global Methane Pledge. For the Arctic Council countries, there's a level here, which is the Russian Federation, which is not currently in the pledge. So the dominating countries here is the US and Russia. And for the observer countries, you can see that the major players there that are not in the pledge is India and China. But if we would combine these emissions, so the ones that are under the Global Methane Pledge with the Arctic Council member and observer countries, we would cover 87% of the global methane emissions. So the Arctic Council could be a forum here for pushing for more methane reductions in these countries that are currently not the major players who are not currently in the Global Methane Pledge, whether it's under the pledge or through some other kind of arrangements. So let us look at also where the different sources are for methane emissions in these 3 groups. As you can see, it's very region-specific where methane is actually emitted. In the Arctic member countries, emissions from oil and gas systems dominate emissions. In the observer countries, you can see that there is significantly more from agriculture, in particular rice cultivation, but also from coal mining. And lastly, in the rest of the world, we have then a lot more from the agricultural sector. But in both the observer countries and the rest of the world, we also have very rapidly increasing emissions from the waste and wastewater sectors. These are the potentials for reductions in the short term, so meaning that the potentials for reducing emissions using existing technologies. So what we can really do in the next 10 years. And here, as you can see, the big reductions is in the oil and gas sectors, that's the brown parts here. And these are reductions that mostly come actually at the net profit, because the gas that you recover or from reduced leakages, it goes to the markets and you can sell it. But it doesn't happen, mainly because of the very high profit margins in this sector. So reductions in methane emissions, even if they are profitable on the paper, it's not enough to compete with a very high profit of actually producing more oil and gas. So we need urgently regulatory frameworks here to really push for binding reductions from the oil and gas industry. And then we have the coal mining with China, Indonesia, I think, as well as in the rest. And there we also have ventilation air methane oxidation technology, which is not coming at a profit but at a low cost. And finally, as I said, for the waste, it's about improving the infrastructure for waste treatment, in particular in many of the developing countries with rapidly growing populations. But the effect of that will probably only be seen after 2030 because of the waste that is already in landfills will continue to generate methane in the beyond 2030. So, thank you very much.
Any quick question for Rita before we move on to our last speaker? Great. Thanks very much, Rita. That was very good. Hopefully you'll be able to join us for the panel discussion. Our fifth and final speaker is Arina Isikova. She's with Carbon Limits in Norway, and she's going to give us a presentation on reducing emissions from the oil and gas sector, lessons learned from the last decade. You're joining us online?
Hi everyone.
There you go.
Can you hear me okay? I assume you can. And I'm seeing my slides in the distance. Excellent. Hi everyone, and first of all, thanks a lot for being able to participate in this event and to present the lessons learned by Carbon Limits, working in the oil and gas sector over the last many years, but today I focus on lessons learned over the last decade. My name is Irina, and I've been with Carbon Limits for the last 7 years, watching the changes happening, the ones that we've been talking about. Our company is a climate consultancy based in Norway, and we focus on climate mitigation with a specific focus on the oil and gas sector. So, like the other speakers, would like to start with the key takeaways first and come back to them throughout my presentation. First of all, from what we observe, there is important progress that is happening already in the oil and gas sector when it comes to short-lived climate vehicles, in particular methane, carbon, particulate matter, and so on. Many of the sources are being addressed, the sources of emissions are being addressed, but we see very drastic changes and differences between the different regions and countries. This is something that Lena has also been presenting in her previous presentation. At the same time, we see new technologies for emissions monitoring, and here in particular I think of methane, emerging and available to the stakeholders, and access to this data can enable better decision making. So there is more information available to plan and strategize and develop mitigation plans which allow companies and countries to act quickly. But at the same time, this needs to be coupled with more capacity building because the level of knowledge and understanding of these technologies is different across different regions. And also, as Lena said, more focus on policy implementation, and I'll come back to that. And finally, again, maybe more on the methane side, the issues of methane emission in the oil and gas sector is quite complex, and there are multiple sources that are not visible to the naked eye. There is many research papers coming out weekly, I would say, on this topic, many new technologies being available for monitoring and mitigation, which makes it complicated for operators in certain regions to follow these discussions and to be able to prioritize them. So I would like to start with one large category of emission sources in the oil and gas sector, which is flaring, which I'm sure all of us are familiar with. flaring emissions from flaring associated petroleum gas, LPG, have been around for the longest time and have been in focus for many years now. Unfortunately, as you see from the graph, the last decade has been a decade of slow progress in flaring, because this black line that you see here, it's stabilized after reducing, and what you see here is not the overall focus from flaring, but the flare intensity, which means amount of gas LPG flared divided by the amount of oil and gas produced in the different countries. So we see that flare intensity has flattened out, we can say, but it doesn't mean that certain countries have not done a lot to reduce their emissions. Actually, there are quite a few success stories across different regions, and here we have a few examples: US, Canada, and Colombia being able to drastically reduce their flaring intensity from the oil and gas operations. We are talking about 50 to 70% reduction over the last 10 years. They have a few, they have a few common traits for the success stories that we are observing. All of the countries managed to have strictly enforced regulations, and here we're not only talking about strict regulations, but also following up on these regulations being enforced properly, which often means having not the municipal capacity and resources to follow this up, and also having some penalties for non-compliance with regulations. In addition, common trait for these countries is that they have a domestic gas market that incentivizes associated gas recovery. And this can manifest itself in many different forms. For example, associated gas can have preferential access when it reaches the transmission gas pipeline, or it can mean good market conditions in terms of price for this gas and good remuneration to operators that actually recover the gas. So seeing both the success stories but also the stalled progress across other countries, we think that there is still quite a bit to be done on addressing flaring. So one of the items we want to do on the next steps is to continue focus and pressure by the international capital markets and consumers to address emissions from the oil and gas sector. We are already seeing this now. We are seeing that the buyers of oil and gas products, as well as investors in these industries, they're increasingly looking for better reporting and better action planning for the oil and gas sector. And we believe that it is important to continue to put this pressure onto the oil and gas sector to reduce further their emissions, and if they cannot be reduced immediately, then to have an actionable plan on how they're planning to do this in the future. Another step that we see very important is to focus on the enforcement of already existing regulations. Many countries have in place quite strict regulations when it comes to flaring. Many ban flaring, so routine flaring, as part of normal operations. Many have high fees for flaring emissions that are produced as a result of flaring. Yet we see that they're not properly enforced everywhere. So focusing on making sure that there is sufficient administrative resources and also the punishment for non-compliance in place should ensure that the existing regulations will be enacted and will lead to results in the And then finally, focusing on financing barriers gas fire utilization can also be one of the next steps. Many of the large players have already been addressed. So many of the players that we are observing are medium and small scale. Still large players as well, but many are of smaller scale, which makes the economics of these projects quite challenging, because in order to utilize LPG, you need large investments in gas processing infrastructure and also sometimes gas transportation infrastructure in order to bring the gas to the market. So it requires large upfront capex, which the companies do not always have the means to finance. And this is again what Elena has been talking about, made this a more profitable ventures are prioritized over this climate mitigation measures in competition for resources and investments. So this was covering our experience related to flaring, and the other large share of emissions come from the oil and gas sector, especially short-lived climate pollutants, are direct releases of methane. And here we're not talking about combustion of methane, we're talking about direct releases into the atmosphere, sometimes called radiative emissions, sometimes called leaks and vents, basically everything that is directly released into the atmosphere. And from our experience, what we did 10 years ago is still true today. So 10 years ago, there were already mature technologies for mitigation of methane emissions, and they remain to be valid and remain to be feasible and available today. We also know that many of the available options for methane emissions in the oil and gas sector, they require much smaller capital investment than, for example, gasification infrastructure, which makes them much more economically viable options for the gas sector. And as said, as well, methane emissions in the oil and gas sector is some of the most lucrative mitigation opportunities for methane across all sectors that climate is related. And what we also know, and still confirming now, is that the emission estimates from the oil and gas sector are highest. So a few things we've learned of the last decade, and one of the big things that has emerged is a number of quantitative technologies, monitoring technologies that have come in. Just like for monitoring flaring, we now can monitor methane with satellite photos. I'm sure you have seen over the last years many news articles related to leaks and vents that have been observed in space. This is important because remote monitoring allows us to make some new conclusions about the nature of emissions, methane emissions from the oil and gas sector. And what we are seeing is that there is high variability in emissions from the oil and gas sector. Not all cycles are alike. Here is an example of one of the regions that we explored, but this is true for regions across the world. We are seeing that a small number of sites are responsible for a large amount of methane emissions. Here, 3% of the sites are responsible for the 60% of emissions. And this is important because if we are able to see where these 3% of the sites are and develop mitigation plans to address emissions from these 3% of the sites, then we have a large share of the problem solved, over 60% of the emissions solved for the specific case, of course. And we are seeing that many of the companies and governments are also highly putting methane in focus. We are seeing that many companies are purchasing equipment and data that allow them to do leak detection and repair. And this is a process to not only identify leaks in the facilities and mitigate them straight away or during next maintenance, but also to map out other sources of methane emissions and plan how companies can mitigate them in the future. In addition, many companies have joined international initiatives related to methane emissions in the oil and gas sector, and here are a few. These initiatives are central to making sure that there is available information, that there is transparency related to methane emissions, and that there is mitigation being done. And finally, on the government level, the methane emissions are being addressed through regulation. We are seeing a few successful examples of not only implementing regulation, but technology respect. So, on the way for methane, we also believe that we need to accelerate action. We see successful examples of mitigation happening both on company level and on regulatory level and country level, but we need to act quickly. So we have 85 months left before 2030. And in order to achieve 1.5 degree target that we're all aiming for, methane emissions should be reduced by 40 to 45%. And oil and gas sector, as I mentioned before, is the only sector where the majority of the methane emissions can be reduced cost effectively. This means that we can mitigate most of our methane emissions globally through the oil and gas sector, and we have to do this. I want to conclude by saying that actions need to be global. There are regional and country examples of successful actions on this already, but it's not enough that 1 or 2 countries lead the way. We need all of the major oil and gas producing countries to do their bit in order to mitigate emissions. Thank you for your time.
Great, thanks very much, Lena. Any quick questions for Lena before we start the panel discussion? No?